Guess what? Tesla just got a reality check from a brand new company. Tesla's always been the big cheese in the battery world, but this new kid on the block just shredded their fancy cyber cell into tiny bits. This new battery is like a superhero. Super efficient, holds more power, and is easier to use. Curious to know more about this battery that's giving Tesla a run for its money? Let's dive in and discover the mind-blowing tech that's got everyone talking. So, who's this hotshot new Tesla rival? It's QuantumScape. They're a cool company from Silicon Valley that's all about making batteries for electric cars. Started in 2010 by Jaydep Singh, Tim Holm, and Fritz Prince, they were just a small fry. But guess what? In 2012, Volkswagen, one of the biggest car makers on the planet, took notice and decided to team up with them. They've been backing QuantumScape ever since. And get this, even Bill Gates himself thought they were onto something and threw some cash their way. But hold on to your hats because QuantumScape really stole the show in 2022 when they unveiled their game-changing battery. Everyone went bananas for it, and suddenly QuantumScape was swimming in cash from all directions. So what's the big deal with this new battery anyway? Let's find out. The battery type in question is QuantumScape's all-new solid-state batteries. You see, solid-state batteries have for a couple of years now been thought of as the future of EV batteries. This is because they're logistically very similar to producing regular lithium-ion batteries. They too are lithium-based, but unlike regular batteries, solid-state batteries utilize solid electrolytes. Regular lithium-ion batteries use liquid or polymer gel electrolytes, whereas solid-state batteries incorporate polymer or ceramic electrolytes, removing all liquid from them. A shift from liquid electrolytes might seem like a superfluous change. However, it allows for an enormous increase in the utilitarian value of the batteries themselves. First, due to a much higher energy density, solid-state batteries have a way bigger capacity, which means they allow for a much greater range while also being way lighter and more compact. This will allow the car to be much more drivable due to a lower curb weight, while also being more efficient because it's not overburdened by excessive weight. The cherry on top is the fact that solid-state batteries have a higher voltage tolerance, meaning that charging times will be much faster than regular lithium-ion batteries, and that is one of the main drawbacks of electric vehicles compared to internal combustion engine cars. But the biggest reason why they're so much better than lithium-ion batteries is that they're also much safer. The biggest concern surrounding regular batteries is how easily combustible they are. You see, regular lithium-ion battery cells combine a flammable electrolyte with a significant amount of stored energy. Once the battery cell starts creating more heat than it can effectively disperse, the battery becomes very susceptible to spontaneous combustion. This process of producing excessive heat is known as thermal runaway, and it can be caused by short-circuiting, mechanical damage, and even overcharging or over-discharging. On the flip side, solid-state batteries are considerably more stable because they can't eject a range of flammable or toxic gases since they're completely solid and lack any kind of easily flammable liquid that can rapidly vaporize. What's incredibly interesting about solid-state batteries is that they existed as a concept for almost 2 whole centuries. Michael Faraday was the first person to discover solid electrolytes back in the early 1830s, which was the basis of all future development of solid-state ionics. However, solid-state batteries have been known for their short lifespan due to the rapid depletion of their solid electrolytes. So what makes QuantumScape's battery so much better than the CyberCell? While the CyberCell battery is without a doubt at the top of the lithium-ion game, it's still conceptually less effective than what QuantumScape proposed. This is because the CyberCell battery is nothing more than an evolution of Tesla's 4680 batteries. And while the CyberCell will beat out most of its conventional competition, it's still nothing revolutionary nor spectacular. First, there's the question of range and production costs. Furthermore, QuantumScape has also done wonders to lower the production costs for its new battery. Solid-state batteries have always harnessed the potential of being more affordable to produce than regular lithium-ion batteries. However, due to them being much less mainstream, these production costs remain high. Thanks to QuantumScape, we've now finally got a solid-state battery that'll be affordable to make. This is because the anode host material, as well as all the manufacturing costs that come with it, have been eliminated. But the biggest complaint and the biggest concern of solid-state batteries has without a doubt been their lifespan. They just couldn't come close to lithium-ion batteries because they lost their potency quite rapidly due to a relatively high strain on them. Well, you can kiss that short lifespan goodbye. Why? Because QuantumScape extended its battery's lifetime massively by eliminating capacity loss at the node interface. As a result, QuantumScape has announced that its batteries will be able to reach over 500 miles without any significant capacity drops or range loss. Furthermore, QuantumScape has also gone above and beyond in creating its new batteries to be as safe as possible. This, apart from shifting to solid electrolytes, also includes the shift from organic separators that are replaced by non-flammable and non-combustible flame separators. This makes the batteries even less susceptible to damage and spontaneous combustion, which should be a major plus in everyone's books. So with all of this in mind, it's safe to say that things aren't exactly looking great for Tesla. QuantumScape has got them pinned down, and with them pioneering solid-state batteries, it's only a matter of time before another manufacturer comes out and starts making their own solid-state batteries, which would lead to the Cybercell's early retirement. Will Tesla catch up? Tesla is a humongous company. Unlike QuantumScape, which is technically a startup and specializes in our Andia batteries, Tesla has enormous production capacities apart from just research and development. What's more, Tesla is also a well-proven company, and their products have been exceptionally popular and revolutionary, whereas QuantumScape is yet to be proven. Not to mention that Tesla can and most likely will buy out any startup competition that might bring them closer to creating the perfect battery type for their EVs. They've already partnered with numerous different companies, and there's no reason for them not to do such a thing with QuantumScape if the company proves to be as ambitious as they keep telling us they are. And that's exactly what brings us to the next problem. You see, QuantumScape's work is yet to be proved or even revealed to the public for that matter. This lack of any visible results is why QuantumScape has been accused of fraud in the past. However, despite these impressive claims, QuantumScape still has a long road ahead to prove its technology can scale for mass production. The electric vehicle industry has seen many battery startups make bold promises, only to struggle with manufacturing challenges and reliability issues when attempting large-scale deployment. One major hurdle QuantumScape must overcome is the actual implementation of its solid-state batteries in real-world vehicles. While lab results may show promising performance metrics, real-world conditions, such as varying driving styles, weather extremes, and long-term wear, can reveal unexpected weaknesses. Tesla, on the other hand, has years of real-world data from millions of vehicles on the road, giving them a significant advantage in refining battery durability and performance. Another factor to consider is charging infrastructure. Even if QuantumScape's batteries charge faster, widespread adoption would require compatibility with existing fast-charging networks, something Tesla has already mastered with its supercharger network. If QuantumScape's batteries require specialized charging stations, it could slow down their market penetration. Then there's the question of cost. While QuantumScape claims its solid-state batteries will be cheaper to produce in the long run, initial costs are likely to be high due to new manufacturing processes and limited production scale. Tesla, with its established supply chains and economies of scale, can produce lithium-ion batteries at competitive prices, making it difficult for a newcomer to undercut them immediately. Despite these challenges, the potential of QuantumScape's technology cannot be ignored. If they succeed in delivering on their promises, they could force Tesla and other automakers to accelerate their own solid-state battery programs. Competition in the EV battery space is fierce, and breakthroughs like this push the entire industry forward. In the end, whether QuantumScape dethrones Tesla or becomes another footnote in battery history depends on execution. The technology sounds revolutionary, but as with any innovation, the devil is in the details. Can they mass produce reliably? Can they secure partnerships with major automakers beyond Volkswagen? And most importantly, can they convince consumers that their batteries are truly the next big thing? Only time will tell. But one thing is certain, the race for better, safer, and more efficient EV batteries is far from over, and QuantumScape has just thrown down the gauntlet. It even performs better in extreme temperatures, making it ideal for a wide range of climates and conditions. Unlike traditional batteries that degrade quickly in cold or hot environments, this new design maintains consistent output and efficiency. That's a game changer for EV owners who live in places with harsh weather.